Let us talk about another very important theorem that is known as Ptolemy's theorem, which says the rectangle contained by the diagonals of a cyclic quadrilateral is equal to the sum of rectangles contained by the pairs of opposite sides. So if I want to understand it mathematically, let us say I've got this cyclic quadrilateral A, B, C, D, A, B, C, D. AC and BD are diagonals. AC and BD are diagonals. Then this Ptolemy's theorem is nothing but AC into BD. AC into BD should be equal to AB into DC plus AD into BC, right? So this is how we write this Ptolemy's theorem mathematically. Now to prove this, let us look at this triangle. Let me change the color first. Let us look at this angle here. If this angle is alpha, let me cut an angle in such a way from here that this angle here is also alpha, right? I can take this angle as angle alpha by construction, right? So let us name these points also as, let us say, P and Q. Okay, now I will focus on these two triangles, this smaller one and this bigger one, ADB. Okay, so let us focus on these two triangles, triangle DQC and triangle DBA. Okay, so in these two triangles, this angle alpha is equal to this angle alpha, right? And can I talk about any other angle apart from this alpha? Yes. This angle here is equal to this angle in triangle ADB. Why? Because if you see that this arc AD subtends this angle and this angle in the same segment of the same circle. Hence these two angles are also equal to each other. So what can I say about these two triangles, DQC and DBA? DQC and DBA, that these two triangles are equiangular. Equiangular. Right? Now you just need to check the correspondence and you can say the ratios of their corresponding sides will be equal. So what are the corresponding sides here? So if I look opposite this alpha, I get AB in this triangle. So AB, and in this triangle, if I look opposite alpha, I'll have CQ. So AB upon CQ will be equal to, and in this triangle, if I look opposite to this angle, I'll get BD, and if I look opposite this angle, it will be CD. So these are the ratios of corresponding sides and these are equal. So if I take the cross product, then AB into CD will be equal to BD into CQ. AB into CD is equal to BD into CQ. Right? You just need to take care of the correspondence. You cannot directly write these ratios, right? So to check the correspondence, I saw these angles which were equal, right? So the opposite sides of equal angles are in the same ratio. So this is one of the relations that I have got, right? Now let us look at these two triangles. This triangle here, this triangle, triangle ADQ, triangle ADQ, and this triangle, triangle BDC, triangle BDC, right? In triangle ADQ, if you look at this angle here, this angle, this is nothing but alpha plus this angle. Let us name it as delta. So this angle, this complete angle, that is angle ADQ, angle ADQ is nothing but alpha plus this delta, right? And if you look at this triangle or this angle, angle BDC, it is equal to this alpha plus delta, alpha plus delta. So I can say these two angles are equal. Angle ADQ is equal to angle BDC. What other angles are equal? If you look at this angle here, this angle, it is equal to this angle. Why? Because these are angles subtended by arc DC in the same segment of the circle. So what can I say about these two triangles? Triangle ADQ and triangle BDC, that these two triangles are equiangular, right? Hence similar. So the ratios of their corresponding sides is going to be equal, right? So the ratios of their corresponding sides is going to be equal. So let me see the corresponding sides. If I look opposite this angle, this will give me side AQ. So AQ divided by, if I look opposite this angle, this will give me side BC. So AQ by BC is equal to, now what other angle? Let us look opposite this angle here. I'll get AD, and in this triangle, in this bigger triangle, let me look opposite this angle. This will give me BD. So AD into BC is equal to BD into AQ. This is another relation that I've got. Now you should know which angles are equal, so you can look at the opposite sides of equal angles and think about these ratios, right? In equiangular or similar triangles, the ratios of their corresponding sides are equal. So this is another relation that I've got. AD into BC is equal to BD into AQ. Now if I add this and this one, what will I get? See, AB into CD plus AD into BC will give me my right hand side, and what will be the sum of BD into CQ and BD into AQ? BD into CQ plus BD into AQ. I can take BD outside, right? So if I take BD outside, it will be CQ plus AQ, which is nothing but, CQ plus AQ is nothing but this diagonal AC, right? So CQ plus AQ is nothing but AC. So this product is BD into AC, right? I can simply say that the product of lengths of the diagonals of a cyclic quadrilateral is equal to sum of product of pair of opposite sides of this cyclic quadrilateral, right? So this is about Ptolemy's theorem, and this theorem is really useful. Let us once more think about this theorem. If I have got a cyclic quadrilateral like this, if I have got this cyclic quadrilateral, right, the lengths of these sides are A, B, C and D, right, and the lengths of diagonals, let us say, are X and Y, then as per Ptolemy's theorem, X into Y will be equal to B into D plus A into C. This is what the Ptolemy's theorem says, and by simple application of concept of similarity, we were able to prove this theorem, right?